Hello, this is the second in a set of videos that looks at an introduction to class hierarchies. And so now we're going to go through some questions about creating instances and using downcasting. So, essentially you need to answer, is this valid or invalid? So vehicle V equals new car. So if we look at this, we always want to think about the reference type and the object type. So we see that this line has a reference type vehicle and an object type car. Remember, references must be the same as object type or a more generic type. So vehicle is a more generic or more general type than car, so this is valid. Truck T equals new truck. Well, since the reference type and the object type are the same, you can see here, that's fine. Bus B equals new motor vehicle. So the reference type is a bus, the object type is a motor vehicle, and notice the reference type here is more specific, so that is not valid. Object O equals new truck. This is valid because, again, object, the reference type, is the root of the hierarchy, so it is a more generic type than a truck. Car C equals new bus. So notice, car and bus sit at the same level in the hierarchy, so that's invalid. Bus B equals new vehicle. So there's their bus, a reference type. Their vehicle's up there, so that is invalid. Remember, the reference type must always be more generic or the same as the object type. Motor vehicle M equals new light truck. So there's motor vehicle, our reference type, there's light truck, and that is perfectly fine because motor vehicle is a more generic type than light truck. So now let's look at some downcasting examples. So let's imagine that we have this code, and we want to state if each of the following is valid, invalid, or requires downcasting. So object O equals Cajun. So if I look here, Cajun is a dog reference, and it is a dog object. So therefore, this line, since object is a more generic type than Cajun, this is valid. Cajun has a dog reference, and O has an object reference. Therefore, since O is a less restrictive reference type than Cajun, this is valid at both compile time and runtime. What about this one? This is invalid. Pet has a mammal reference, so we go up here, pet has a mammal reference, and S has a samoyed reference. Since mammal is a less restrictive type than samoyed, this is invalid at compile time. The pet object has a dog, so basically what I'm saying is at compile time this doesn't make sense, because what it says is you have a mammal reference, I'm going to assume this is a mammal object. So at compile time it's going to say this isn't good because samoyed, the reference type, is more specific than mammal, which it will assume pet is a mammal object. So once we've evaluated compile time, we need to then look at runtime. So at runtime, pet is a dog. But again, dog is a more generic type than samoyed, and so since, remember, the reference must be more generic than the object. So since samoyed is more specific than pet, which is a dog at runtime, downcasting doesn't fix this problem. Samoyed S equals Cajun. So again, we're going to look at this in two ways. We're going to look at this at compile time, and we're going to look at this at runtime. So at compile time, what do we see? We see that dog Cajun, so it's a dog reference, so we're going to assume a dog object. And then we're going to look, and then at compile time, so samoyed S. So at compile time, what we see is we see that samoyed is a more specific type than a dog, so it's invalid. So then at runtime, we have a dog object. You can't have a samoyed reference to a dog object, so this is invalid. Cajun has a dog reference, and S has a samoyed reference. Since dog is a less restrictive type than samoyed, this is invalid at compile time. The Cajun object is a dog object type. The reference must be the same as or less restrictive than the object type. Therefore, downcasting does not fix the issue here. What about this one? Sumoid S equals Toby. So again, let's talk about compile time. Toby at compile time is a dog, and so when we evaluate this at compile time, what we see is that the reference is Sumoid, and the object is going to assume is a dog, and Sumoid is a more specific type than a dog, so therefore this is invalid at compile time. So now let's see if downcasting fixes our problem. So at runtime, we're going to create a Sumoid object, which means Sumoid S equals Toby is valid. So this is a case where downcasting will fix the problem. So Toby has a dog reference and S has a Sumoid reference. Since Sumoid is a more restrictive type, this might be valid, but the object type of Toby must be known to be sure. Only if the object type of Toby is a Sumoid or a more restrictive type, which there are none in this case, will this be valid. At runtime, Toby is constructed as a Sumoid object. This means downcasting will reassure the compiler that this will work at runtime and is needed for the program to compile. And that is how we would downcast. What about this one? So again, we check at compile time. Compile time, mammal, sorry, we're looking at Toby. So at compile time, we have dog Toby, so we're going to assume this is a dog object. We come down here, so I have a mammal reference to a dog object, which is perfectly valid. So, since dog can only have an object of equal or more specific type, that means this is valid regardless. Downcasting does not have to be used. Dog D equals pet. So, mammal, pet. So pet has a mammal reference. So at compile time, we're going to imagine that this is a mammal object, which is invalid because mammal is a more generic type than dog. Remember, general to specific. So now we're going to look at trying to decide whether or not downcasting is useful here. So if the pet mammal reference points to a dog object, so therefore at runtime this is actually a dog object. So the dog reference can point to a dog object, so this is where downcasting would be useful. And that's how we would fix that. So like I said, this stuff can get very confusing. The best way to get your head around downcasting and basic class hierarchies is to try and program some for yourself. And in our later videos, we're going to be doing that, just that. And just as an ending thought, this is the part of the Java hierarchy. So down here is part of the Java hierarchy. Look at the classes that are boxed in red. All these classes have a related trait we will explore in the near future. Take a look. See if you can figure out what it is.